Okay, so see this thing. Have you ever tried to analyze the motion in outer space? What will be the possible answer for this? See, let's see some example. Okay, see, basically, when we consider something, the motion under under the gravitational influence, then we should consider the laws of motions. So, what will be the learning objectives of this session? Newton's laws of motion and forces, application of Newton's law of motion, friction, circular motion. Now let's revise some initial thing that we have learned in 1D motion. First is equation of motion. These three equations of motions are there when an object moves along a straight line with uniform acceleration. You have v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, where u is initial velocity, v is final velocity, s is displacement, a is acceleration, t is time. Now see the problem. A train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the distance traveled by the train for attaining this velocity. So first you change it to meter per second, 72 into 5 by 18. Okay, then this is starting from rest, so u is 0, so this will be the v, and in the 5 minutes, so 300 seconds. Okay, and assuming this is in uniform acceleration, find the distance. So what you should do for this case, initially you need to find the acceleration, after that you can find the distance. So you can do v square is equal to u square plus 2as. V square is equal to u square plus 2as. V square is 72 into 5 by 18. Okay, so 20 meter per second. And then or you can use v is equal to u plus 80. Okay, then you will find the acceleration, that should be 1 by 15. Then v square is equal to u square plus 2as. From that, uh, v square is 20 square, u square is 0 square, plus 2 into a is 1 by 15 into s. So s is equal to 3000 meter, so 3 kilometer. Okay, now revision. Circular motion, v is equal to omega r. V is linear velocity, omega is angular this angular velocity, r is radius. Okay, now ac is the uh, centripetal acceleration ac. So ac is equal to v square by r, so it is omega square r, and omega is equal to 2 pi by t. Omega angular speed, that is 2 pi by t. Okay, and momentum, we know p is equal to m into v, mass into velocity. Okay, now if a particle is moving in a circle of radius 0.5 meter, then find out its magnitude of its radial acceleration if linear speed of the particle is 1 meter per second. So what you should do, acceleration v square by r, so v square is 1 square by 0.5, so 2 meter per second square. Correct. Now Newton's laws of motion and forces. So what will be the, in this case, first force, what do you mean by force? Newton's first law of motion, inertia. Newton's second law of motion, impulse. Newton's third law of motion, common forces in mechanics. All these things will be your learning objective. Okay, so first thing is force. It is a physical quantity which either causes change in configuration, change in motion, or it tends to cause change in motion. Okay, so it is a physical quantity which either cause change in configuration. That means if you apply force on some object, either it will basically change the dimension of the object, it will have some dent or something, elongation something, or compression. Okay, it will have some dimensional change or change in motion also, or it tends to cause the change in motion. Okay, so here you can see this fellow is actually pushing this box. Okay, Then generally when the force is get basically applied with it, so it basically changes the state of motion. So initially it is in rest, now it is in motion. Okay, next, motion to rest. So see this thing, suppose an object is actually moving and you are applying force against it, so it is from motion to rest condition. Then tendency to cause change in motion. So this fellow is basically pushing the wall, but this wall is not moving, but still is applying force, so it basically have tendency to cause change in motion. Okay, change in configuration, you can see this thing, this mattress is basically pushed. Okay, and you can see this type of deformation. So this change in configuration will occur when you apply force. Okay, now let's discuss the first law of motion. So see the statement first. Body at rest continues to remain at rest, and body in motion continues to move with uniform velocity until unless an external force is applied on it. Okay, now the question. See for the challenge. Calculate the net force acting on a car moving with a constant velocity of 30 km per hour on a rough road. What will be the possible answer for this? See, constant velocity, uniform motion, no change in the state of motion. Therefore, as per the first law, net force acting on car is 0. Then inertia. See, the property of opposing to change in state of motion is known as inertia. So there are two type of inertia: inertia of rest and another inertia of motion, another inertia of direction. Now you just see this thing. If you consider this object, if you consider this object is actually rotating. You see the ball is rotating about a fixed center. This ball is rotating about a fixed center. Okay, now what do you mean by inertia of rest, inertia of motion, inertia of direction? See, first thing, whenever you are basically um, standing on a bus, okay, or any vehicle, you're standing on it. Suddenly it starts moving. So what will happen to you? What will happen to you? You basically fall back, isn't it? Your head is basically bent, the upper portion of your body bent towards the backward direction. Why? Because when you are standing on a car, on a vehicle, then what will happen? The lower part, as soon as the vehicle is in motion, the lower part basically approach in the forward direction, whereas your upper part, due to the inertia of rest, will not move. So you basically fall backward direction. Okay, your upper part will fall backward direction. Inertia of motion, you were standing on a bus, suddenly the bus was in motion, suddenly it stopped, and basically what will happen? Your upper part, so you basically fall forward direction. Your upper part tends to bend in forward direction. Why? Because what will happen, the lower part suddenly gets stopped when the bus basically brakes. Okay, and stopped, suddenly stopped means what? That means it is, the lower part is basically move along with the bus. So suddenly stop means it is in the rest position, but your upper part, due to the inertia of motion, will not come into the rest position. So that is why it bends in forward direction, so you will fall in forward direction. Inertia of direction means the tendency to not change the direction of the motion. You can see in case of this ball, this red colored ball, which is tied with a rope at a center. When you rotate it, it will rotate about a fixed orbit, or I can say at a fixed radius. And generally it doesn't want to change the direction. Okay, Now see, mass is the measure of inertia. Okay, mass is the measure of inertia. Like 10 kg mass is there, 100 kg mass is there. Which one having more inertia? 100 kg, due to the more mass. So mass is the measure of inertia. What you can do, suppose force 10 newton is applied at it on a 20 kg object, then what will happen? It will get displaced. It will get displaced at a d distance. Okay, when you apply 10 newton to 10 kg. But if you have 100 kg, you should apply 100 newton of force to get the same displacement. So for kg you apply 10 newton, for 100 kg you need to apply 100 newton, then only you will having same type of displacement. Otherwise you will not have same type of displacement. Okay, that means what? For less mass you need less force, for more mass you need more force to get the same amount of displacement. That means what? The more mass means more inertia. That is why you need more force to overcome it. Now the second challenge. When a carpet is beaten with a stick, dust comes out of it. What will be the explanation? Both carpet and dust particle are at rest. So case of inertia of rest, carpet is beaten and it comes to motion. But dust particle try to remain at rest. So they get separated. Next one. Why are the passengers thrown backward when stationary bus suddenly speed up? I told you earlier. Okay, so bus and the passengers are at rest. So case of inertia of rest. So bus suddenly speed up in left direction, you can see. So the lower part is in motion with the bus, but the upper part, basically lower part of the body becomes body comes to motion, and the upper part of the body tends to remain in the rest. So as a result, passengers are thrown backward. Now the second law of motion, that is this basically, if a net force is acting on an object, the object will accelerate. And if a net force is acting on an object, the object will accelerate. Then acceleration depends on directly proportional to the net force, okay, and inversely proportional to the mass. A is equal to net force by mass. So net force is equal to m into a. Now acceleration is equal to v minus u by delta t, rate of change of velocity, and mv minus mu is nothing but initial final momentum minus initial momentum divided by change in time. So the rate of change of momentum of a body is directly proportional to the net force applied and takes place in the direction in which the force acts. Now the challenge. A stone of mass 0.05 kg is thrown vertically upward. Give the direction and magnitude of the net force on the stone during the upward motion, during its downward motion, and do your answer change if the stone was thrown at an angle of 45 degree with the horizontal direction? First case, the stone moving upward direction. So in this case, you see, so here the first case, this ma is nothing but mg, same value. So m is 0.05 and g is 10, so 0.5 newton downward. Next case, when it is down moving downward, then it is the same value. Okay, but when it makes an angle 45 degree, then what will happen? What will happen? Direction and magnitude of the net force on stone, will it all alter or not? It will not alter even it is thrown at 45 degree, because no other acceleration except the gravitational acceleration is acting on that stone. Okay, actually this concept we have actually discussed in projectile also. Okay, we know the vertical component is actually having that acceleration, but whereas the horizontal component doesn't have any acceleration, so that will maintain the uniform motion. Okay, and we have seen a graph over there where we can see the vertical component when it is moving upward direction, how it is getting reduced, and at a maximum height it becomes 0, still there is a horizontal component. Again, when it is coming back, then initially the velocity increases, and when before it touches the ground, it will be the maximum value for that, vertical component of the velocity, while the horizontal component remains same. Now, a body of mass 5 kg is acted upon by two perpendicular forces, 8 Newton, 6 Newton. Give the magnitude and direction of the acceleration of the body. Okay. See, 8 Newton and 6 Newton, two forces. Resultant, square root of 8 square plus 6 square. So 10. Now, we know F is equal to ma. So, A is equal to F by m. So, F is 10 Newton. M is 5. So, 2 meter per second square acceleration. Now, tan theta. If you see the triangle, theta is equal to this opposite by adjacent. So 8 by 6, that means 4 by 3. So tan inverse of 4 by 3, 53 degree with 6 Newton. See that in this question, the driver of the three-wheeler moving with a speed of 36 km per hour sees a child standing in the middle of the road and bring his vehicle to rest in 4 seconds, just in time to save the child. What is the average retarding force on the vehicle? The mass of the three-wheeler is 400 kg and mass of the driver is 65 kg. So see, 36 km per hour change into meter per second. Okay. So, and the total mass, because the vehicle mass was 400 kg and driver mass was 65. So 465 total mass, and 36 if you change it becomes 10 meter per second. And when it is finally comes to rest, so v is 0, t is 4 second. So acceleration first you have to calculate, and you will be getting that is minus 2.5 meter per second square, because it basically stopped now, so it retarded. So the retarding force will be mass into acceleration. So mass is 465 into minus 2.5. So is minus 1162.5, or I can say it is 1.2 into 10 to the power 3 Newton retarding force. That is why it is minus. Now the impulsive force. It is the large force acting for a short period of time to produce a finite change in momentum. So impulse is equal to force into time duration, but it should be short time interval. So change in momentum, it will cause change in momentum. Now the question: a batsman hit back a ball straight in the direction of the bowler without changing its initial speed of 10 meter per second. If the mass of the ball is 0.12 kg, determine the impulse imparted to the ball. I assume linear motion of the ball. So we are not assuming any kind of projectile in this case. Okay. Okay. Now see the initial velocity and the final velocity. Why we have taken? Because initial velocity was 10 meter per second. Okay. And it is hit back without the changing its initial speed of this. So it basically change in the direction. Okay, so if we consider initial velocity, because if we consider the ball is basically throwing in the leftward direction, so we can consider minus for that, and when it basically comes back it is positive, but the magnitude is same. So minus 10 meter per second and 10 meter per second. So minus 10 meter per second initial velocity. Why? Because it is towards left side, and if we consider the reverse side, that is plus 10 meter per second. Okay. Okay, you can assume either of this, like you can assume this, just reverse of it, but you just think, generally what will happen in your screen, the ball thrown in which direction? Generally left side na, towards the batsman. So that is why it is taken negative. Okay. Now change in momentum, final minus initial. Final is 10 into 0.12, because it is 0.12 kg. Okay. And minus 0.12 into minus of 10. So actually it is 2.4. Minus minus become plus. Okay. So impulse is 2.4 in the direction from the batsman to the bowler. Now the next question. A batsman deflects a ball by an angle of 45 degree without changing its initial, which it is 54 kilometer per hour. What is the impulse imparted to the ball? Mass of the ball is 0.15 kg. Okay. Now see, AO is the incident path of the ball. Incident path of the ball means if RS, if we're considering a bat, if RS is considered to be a bat, AO is the incident path of the ball. Correct? RS has to be the bat and AO is the incident path of the ball. Correct? Now OB is the path followed by the ball after deflection. Okay. So AOB, angle between the incident and deflected paths of the ball. And if AOB is 45 degree, AOP and BOP is 22.5 degree. That is the theta, half of it. Okay, AOP and BOP is 22.5 degree. Now initial and final speed of the ball 54 kilometer per hour. So change into meter per second, 15 meter per second. And mass of the body means what? Thus, mass of the body means the ball 0.15 kg. So 0.15 kg m. So P initial is equal to mu cos theta. P final is equal to minus mu cos theta because it is getting back. P initial, it is mu cos theta. Moment. It is basically your momentum. P initial, but x direction. That is why it is given Px initial. M into u, mass into u cos theta. M mass, u cos theta is velocity component along the x-axis, and Px final, that is final momentum, is equal to minus mu cos theta. Why minus? It is reverse direction. M into minus u cos theta. Okay. And Py initial, it was minus mu sin theta. Py final is equal to minus mu sin theta. Because see, uh, if you have the two component, if you have the first thing like it is coming in this direction, so this will be your uh, in this direction. If you want to draw it, this will be the direction of like y direction and velocity, and here will be another direction of, so both of them are in, it is in downward direction, so that is why both of them are negative. So minus mu sin theta, minus mu, so minus 2 mu sin theta. Okay. So change in momentum in uh, x-axis is actually minus 2 mu cos theta. And why? Because here it is final minus mu cos theta. This final minus initial is actually the change in momentum. So minus mu cos theta minus mu cos theta, so minus 2 mu cos theta. And here it is final minus initial minus mu sin theta minus minus plus mu sin theta, so these two get cancelled. But here these two will give you minus 2 mu minus 2 mu cos theta, minus 2 mu cos theta. Okay. So change in momentum in x direction is minus 2 mu cos theta. Change in momentum in y direction 0. So the impulse imparted to the ball is change in momentum. So minus 2 into m into cos theta, cos 22.5. Okay. And then you will be getting 4.14 kg meter per second. Okay. Now the third law of motion. See this thing. Here you can say, see in this case, this balloon which is fitted with this straw and basically pass through a thread. When it is released, when you release the balloon, because there is an opening, if you release the balloon means what will happen? From this direction the air will come out from the balloon. So if the air mass of air is injected from this direction, so the balloon will move in this direction. That is why this balloon is moving in the front direction. This thing is moving in the opposite direction. Okay. So okay. So now for every action there is always an equal and opposite reaction. Okay. So objects interact like mutual force of the same nature arises on both bodies. Forces are equal in magnitude. Forces act in opposite direction, and force don't cancel each other because they act on different bodies. These are the important and vital points to remember. Okay. Again, I'm repeating objects interacting. So mutual forces of same nature arises on both bodies. Then forces act in opposite direction. Forces are equal in magnitude. Force don't cancel each other because they act on different bodies. Now thus this thing. You see why the boat moves back when the sailor jumps in forward direction. You can see somebody is jumping from the boat and the boat is moving backward direction. Okay. See, the sailor jumps out of the boat and the boat basically going in backward direction. The direction of that boat is backward direction, correct? Just a second. Going backward direction. The boat, the man jump out in this direction, the boat is in backward direction. Okay. So this that means it presses the boat with feet. So by third law, there will be an equal and opposite reaction. By third law, there will be an equal and opposite reaction. Both exert a force. Both exert a force. Both exert a force on the man. Okay, and the man exert the force to the boat. So the boat basically move in the backward direction. The earth pulls a stone to downward due to gravity. Does the stone exert a force on the earth? So yes, according to the Newton third law of motion, the stone does exert an equal and opposite force on the earth. We do not notice it since earth is very massive, and uh, the small forces on the motion is having negligible effect. Okay. So common forces in mechanics. First, weight. W is equal to m into g. Normal reaction. Normal reaction, it will be normal to the surface where the body kept. So it will be perpendicular to it. It will be perpendicular to it like this. It will be perpendicular to it. Okay. Because if you basically apply force vertically downward on a surface, then the normal reaction will be opposite of it. Now friction. If some object is getting pulled with the help of this force capital F, then the green color small f denotes the friction in opposite direction. Okay, so that is how the friction is getting denoted. Tension, something is basically hanging from ceiling, so this string is actually having tension in opposite direction, like in upward direction, against the weight of it. Spring force is also there. If you basically pull this thing object, the spring actually having a force, spring force F, which is equal to minus k into x, where k is spring constant, x is compression, and the negative side denotes the force is opposite to the displacement from the unstretched state. Okay, so these are all the important topics to be done. Now application of Newton's law of motion. So the learning objective will be free body diagram, equilibrium of particle, conservation of momentum. First, free body diagram. So system is that the part of a body in which we are interested. See this thing. Here you have this 5 kg object and 15 kg and 5 kg over here. Two pulleys are there. Interested in motion of if you are interested in motion of 15 kg, 15 kg means this one only. So only this object has to be drawn separately. See 15 kg, it is like that. Step to draw free body. Draw a sketch of the situation like this. Then identify the system, the mass, identify all external force on the object, all the external like the normal reaction in upward direction and downward direction the weight. Okay, repeat these steps for all system, then you will be getting the free body diagram for the system. A block of mass m is suspended with two string as shown in the figure. Draw a free body diagram of the block. See this thing, this block m is suspended with two string. This is one string, this is another string, it is suspended like this. So how can you draw free body? The body should be like this, one force in this direction with x-axis, another in this direction like that. So you can see the tension on T1 is with theta with the horizontal and T2 in vertical, backward, sorry, horizontally backward, and mg is the downward direction weight. Draw the free body diagram of the masses and pulleys for the given sketch. See the mass m and m is here. This is a frictionless pulley over here, and this is basically a string or a rope. Now how to draw it? You just draw the masses first, m, you draw the pulley also, you draw, and then you will give the, for m mass, the upper mass, you give the tension in this direction. So we have to give tension in this direction, and it has mg weight in this direction and normal reaction in this direction. And then it has, if you consider this part, it has tension in this direction, and reaction in this direction. Okay, now you consider the mass below this mass, like this mass. So this tension is upward direction, downward direction your weight, and mass is here. So if the string and pulley are massless and pulley is frictionless, then tension in the string will be the same throughout the string. Like if the string and pulley are massless and pulley is frictionless, then the T all over it, like T1, T2 we have given now, all will be T, no change of the tension. Now equilibrium of particle. Equilibrium of particle in mechanics refer to the situation when the net force acting on it, on the particle, is zero. F net is zero. Now you see these forces F1, F2, F3. F3 makes 60 degree with the horizontal direction. F2 is already in vertical direction. F1 is horizontal direction. Now three forces in equilibrium condition should be zero. Then you just give, this is actually vector from f1xi plus fy1yj plus f1zk. Similarly for f2xi plus f2yj plus f2zk plus f3xi plus f3yj plus f3zk. Actually in ijk, in vector form, we have basically separated all all these three forces, that is equal to 0. Now you just separate I, J, K. So all the three I's you just take and take common, three J's take common, three J take common, and then that has to be in this form. Now a body of weight 100 Newton is suspended from the rope tied to other ropes at point O. One rope is horizontally attached to wall and other is fastened to the ceiling. The angle between ceiling and the rope is 60 degree. What are the tension each of the rope? What are the tension in each of the rope? Assuming the weight of the rope and the knot are negligible. Okay, so tension all over will be same. First, the free body diagram T1, T2, T3 you have taken. So in 60 degrees, so T1 sine 60, T1 cos 60, because if this is 60 degree, it should be cos, it should be sine, and this is T2 and this is T3. Now what should you do? First in x direction, you just resolve all the forces in x direction. So T1 cos 60 here, this direction positive, minus T2 negative is equal to 0. So T1 cos 60 is equal to T2, the first equation. Then in y direction you see this is positive, T1 sine 60, then minus T3 is equal to 0. So T1 sine 60 is equal to T3, equation 2. So after that, T3 minus W is equal to 0, T3 is equal to W, that is 100 Newton. From equation 2 and 3, you get T1 is equal to 15.47 Newton, and that is equation 4. And equation 1 and 4 will give you T2 is equal to T1 by 2. So T2 is equal to 57.73 Newton. Now two blocks of equal masses M are tied to each other using a light inextensible string. One of the block is pulled along the line joining them with a constant force F. Find the tension in the string joining the block. See, B and A, these two blocks joined with the string, and the force is applied in this direction. These two blocks, if you are taking individually free body diagram for A, Na is the normal reaction, mg is the weight of that object A, T is the tension in the leftward direction, F is the applied force, and acceleration will be in the direction of the applied force. And then nb is the upward direction, normal direction for B, mg is low, just downward, opposite to nb, tension in the direction of the object A, and definitely acceleration will be in this direction. Now if you apply Newton's second law of motion on the block A, so net force is equal to m into A. Net force is that F minus T, this is the net force, is equal to ma mass into acceleration. So this is the first equation. On block B, it is tension is equal to mass into acceleration, that is the net force on it. So from equation 1 and 2, tension is equal to force by 2. See this thing, two masses 8 kg and 12 kg are connected, and at the two ends of the light inextensible string that goes over a frictional pulley. Find the acceleration of the masses and the tension in the string when the masses are released. So you see in this case, in pulleys two masses are there, 12 kg in downward, 8 kg little bit up of it, but the weight of both of them is acting downward. So a 12 kg is accelerating downward A1 and 8 kg accelerating upward A2. So see this case in free body diagram. 12 gram is for that gram force, that if you see that G, 12G actually. What we're taking 12G, because 12 kg into value of G, that is your weight. 12 kg is mass and G is 9.8 if you take. So 12G, it is saying it is nothing but W. W is equal to M into G, na? M is 12 and G is that. Here also M into G. And so x1, x2 for both the cases x, and v1, v2 is v, and a1, a2 is a if you are taking. So T minus 8G is equal to 8A. Why? T is upward direction, minus 8G is equal to 8A. 8A means M into A. And 12G minus T is equal to 12A. Now from equation 1 and 2, acceleration is equal to 0.2 gram. So sorry, 0.2 G, not gram, 0.2. Then G, if you multiply, if it is you are considering 10, then it will be 2 meter per second square. So putting the value of acceleration in equation, T minus 8 into 10 is equal to 8 into 2. So T is equal to 96 Newton. Now conservation of momentum. Conservation of momentum, if you consider that thing, UA is the velocity, initial velocity of A, UB is the initial velocity of B. Now moving towards right with the velocity UA and UB, where UA is greater than UB, they are first consider the system is isolated, no external force is acting on them. Then both ball collide, UA collide with UB. Collision lasts for small time t. So each ball exerts same force on each other. So ball moves with the final velocity VA and VB after collision. Then initial momentum MAUA, okay, and that for that MBUB. Final momentum MAVA, and for that MBVB. So the rate of change of momentum MA common VA minus UA by T, and it is MB common VB minus UB by T. So from that concept, the rate of change of momentum FAB and FBA, both of them you are getting. So FAB and FB are action reaction pair of forces. So you can say from third law, FAB is equal to minus FBA. So MA into VA minus UA by T is equal to minus MB VB minus UB by T. TT get cancelled. So you can have MAUA plus MBUB is equal to MAVA plus MBVB. Okay, the total momentum of an isolated system of the interacting particle is conserved. So initial momentum is equal to final momentum. So two objects of the masses 100 gram and 200 gram are moving along the same line and direction with the velocities of 3 meter per second and 1 meter per second respectively. They collide, and after the collision, the first object moves at a velocity 1.2 meter per second. Determine the velocity of the second object. So masses are given, velocities are given. Now you check. So 3 meter per second, object A moving towards B, that is having 1 meter per second before collision. After collision, what will happen? A will move with 1.2 meter per second. You need to find for B the velocity. So P initial is equal to P final. P initial means initial momentum, ma ua plus mb ub, and final momentum ma va plus mb vv. So you put the value. Ma is 100, ua is 3, mb is 200, into ub is 1, ma is 100, va is 1.2, plus mb is 200, but you don't know vb. So vb has to be calculated, that is 1.9 meter per second. That is for today's concept. Okay.